Thank you, everyone, so much for coming to this talk this morning. And I'd like to start by saying a huge thank you to Domain-Driven Design Europe, the conference itself. Matthias and Annika do such a wonderful job, and the whole crew. I'm sure you'll agree with me what a wonderful experience this is. And of course, we have yes, thank you. And we have to say thank you also to the technical crew who make this thing happen, and the caterers, and the whole army of people that come together. But certainly not least, it's you, the people you here coming into the audience and coming and sharing knowledge and experiences with each other and building this community. You not only make events like this possible, you make it worthwhile, so thanks for coming. I'm very excited to share this talk with you today, a defense of technical excellence. And you might find yourself wondering, why on earth would technical excellence need defending? Who doesn't want to be technically excellent? All of us, right? Like Bill and Ted on their adventure. We want to be professionals. We want to do good work. We want to create quality code. But I think many of us, and hopefully you will agree, and I'll share some stories to sort of make this case, that our industry is in a period where this kind of belief is under attack. So let me share some stories with you to kind of illustrate my point. Imagine you're in a software development team. One of your stakeholders arrives and they says, I've got such a great new idea for this product. I'm going to package it up, describe what I want, put it in the backlog. That is the Jira icon, for those of you fortunate enough not to know what it looks like. The dev team, of which we are members, come along and we get stuck into it. We think, okay, we understand what we have to do. We know how to code. We start coding. Inevitably, nothing wrong. Sometimes people make mistakes. Our friendly QA engineer comes along, blows up all our hard work and says, I'm sorry, my friends, but I found a bug. No problems, we'll fix it. Not so fast, says somebody. Maybe it's the engineering manager, maybe it's the product manager. We haven't got time for that. Just get it live, our customers are waiting. We'll put the bug on the backlog and deal with it later. So it goes into production with a bug. Who here has seen themselves in this story? Yes, I think almost everybody has put their hand up. Here's another story. Similar start. Our product manager comes along, here's a new feature, I'd love you to add to the product. Put it in the backlog, we come along and start working, and we say, this one's quite tricky actually. We're going to need some time to think about this. We'd like to get a whiteboard, maybe some butcher's paper, do a bit of modeling and design work. And we get told once again, no, we are a rocket ship on our way to the moon. There's no time for design. Just get coding. So we code, we go to production, and we leave a little gift for our future selves, this stinky pile of garbage in the corner. Who's been in this situation? Once again, almost everybody has raised their hands. Our last story starts very similarly with our product manager with a lovely new idea, adds it to the backlog. The team gets started. Now they know they're not going to be allowed to do any design, so they get stuck into the coding. And of course, they encounter their little gift that they left for themselves before. So of course, this adds delays. And because of the delays and the confusion, our friendly QA engineer comes along and blows things up again. We find another bug. But we have no choice. We go to production again, but our gift is bigger. The gift we're leaving to our friends, that stinky pile of garbage, is now bigger. Who's been in this situation? Yes. Once again, we have people with both hands up, I'm sorry to say. So hopefully you can see now what I mean when I say technical excellence needs defending. What I just did with you is shared 3 stories. I want to take a step back, a bit of meta commentary now. This is a kind of thing called an intuition pump. An intuition pump is something that was proposed by the philosopher Daniel Dennett in his book, optimistically titled Consciousness Explained. It is a wonderful book. I wouldn't say it has fully explained consciousness just yet. But he describes an intuition pump as like a thought experiment, not really a formal argument. They're stories, little fables. They're supposed to teach us something. And when they do it, they lead the audience to an intuition, a conclusion. When you pound your fist on this table or throw both hands in the air and say, yeah, it's got to be that way, doesn't it? It's a persuasion machine. So I've told you these stories as a kind of intuition pump to help you think about, the world that I'm describing and that I've experienced. But it's interesting because the cause of what those stories that we experienced was also a kind of intuition pump. And my experience has been that it's an intuition pump called the iron triangle. It's not a fact. It's a story that people tell themselves about how the world works. If you've heard of the iron triangle, you might have heard it described as this kind of inevitable trade-off between scope on one corner schedule or time on the other, and cost on the third. We can vary any one of these, but we have to have some give in the other two. Very interestingly, if you go to Wikipedia and look up the iron triangle, it will tell you that quality stands in the center, that quality is the fixed, unchangeable characteristic that we are trading off around to preserve. In fact, it describes the iron triangle in these three terms. The quality of the work is constrained by the budget, deadlines, and scope. The project manager can trade between the constraints, but changes in one constraint necessitate changes in others to compensate, or quality will suffer. No, we can't let quality suffer. I have to say, I've never worked in an environment where anyone invoked the iron triangle in this way. So I got curious about the history of this. Why is it described in this way? And it turns out that it was originally described by Dr. Martin Barnes back in 1968, and he characterized it as cost, time, and resources. How long do you think it took from 1968 before someone decided that quality was a negotiable in this trade-off? If you guessed 1969, you're correct. In 1969, Dr. Martin Barnes came along and he prepared a training course called Time and Money in Contract Control, which was the term for project management in those days, before project management was a thing. And he said quality is something that can be traded off. Now, he was working in civil engineering. I'm not a civil engineer. I've never worked in that space. I can't speak to whether that's appropriate or not. But what I can say is that this metaphor, this intuition pump, has definitely proliferated. We see it all over the place in a very ambiguous way. This top corner of the triangle, sometimes it's scope, sometimes it's quality, sometimes performance, sometimes it's the goal that we have or the product idea that we want to deliver. In all these situations, it represents the outcome, some kind of aspect of the outcome, whereas the bottom two corners represent the inputs. We have time and money we're putting in, we're getting something out, and we're trading off between all of them. Now, in one sense, this has been a helpful device, even for those of us who work as engineers and building systems, because we've used it ourselves as a defense against unrealistic expectations. You can't have it, all three. You can't have an amazing quality product for that budget in that time. And I think that's not an unreasonable use of it. But the iron triangle is then used against us sometimes when people say, look, we're going to have to sacrifice quality because we need to get speed. We need to trade off quality for speed. And more colloquially these days, you often hear it expressed in this way: good, fast, or cheap, pick two. You've heard this phrase? Maybe you've used it. Maybe it's been used against you. Either way, hopefully you believe me now that this is not a fact about the universe. It's an intuition pump that people use to justify the things that they want to achieve. I'm going to introduce you to a different intuition pump today, something that we can use to craft our own narrative and help us make sense of what's going on, and in particular, why the iron triangle and this trade-off doesn't work. Anyone read this book, Thinking in Systems by Donella Meadows? Yeah? Decent number of people. If you come to DDD Europe regularly, I'm sure you've seen it referenced in many other talks. It's definitely an institution in the field of systems thinking, and it's a wonderful introduction to many of these ideas. I do recommend checking it out if you get a chance. One of the ideas in this book is the concept of a causal loop diagram, and that's what we're going to be using today. I'm going to go back to my laptop and show you a few causal loop diagrams to build your own intuitions and to help you learn how to use these tools to sort of make the case, to tell the story that you want to tell about what's happening in your environment. We're going to use a tool called Loopy, which is a lovely open source tool. It just runs in the browser. You can get it on GitHub. It was developed in 2017 by Nikki Case, and then in 2020, Millicent Biet took over maintenance. And as you'll see, it's got some nice visuals, and we're going to play around with it today. So let me come back over here, and we'll take a look at a couple of causal loop diagrams. Now, I'm going to start with something very simple. Oh, we've lost the full screen. This is the tool, Loopy. We've got one node here in the middle. I've called it rabbits. So we're going to do a couple of simplified models just to get your intuition going for how these things work. When you start this tool, you can simulate more rabbits or less rabbits. But in this situation, there's not much going on. We haven't really got a system or a causal loop in reality. So let's take a look at what happens when you think about where do rabbits come from. Well, they come from baby rabbits, right? So now we have an interaction between two nodes. And if we increase the number of baby rabbits, we get more rabbits. If we decrease the number of baby rabbits, we get less rabbits. We've drawn a connection between these two nodes. This connection has, in this tool, an equals sign. The equal sign represents the fact that the relationship between the two is that they move in the same direction. Sometimes you'll see these drawn with a little plus symbol, sometimes with the letter S, which is short for same. But either way, if we go up on one side, we go up on the other. If we go down on one side, we go down on the other. Pretty straightforward. But I'm sure you can see this is not the full story either. We're going to take a look now at what happens when we think about where do baby rabbits come from. So we've got baby rabbits. With the more baby rabbits, the more grown rabbits. I'm not sure where this @ symbol came from. I think my laptop is confused about being in Europe and it's getting some Unicode issues. But anyway, if we have more rabbits, baby rabbits, we get more rabbits. We have more rabbits, we get more baby rabbits, and so on. So this has now set up our first causal loop. This is what's known as a reinforcing feedback loop. It's called reinforcing, as indicated by the R in the center there, because in whatever direction it starts moving, it will continue to move in that direction. I've shown you what it looks like when it's moving upwards, but also it can move downwards. If you have less baby rabbits, we get less adult rabbits, less baby rabbits, less adult rabbits, until eventually the population dies out. So whether the population shrinks and decays to nothing, or whether it increases and explodes to the point where it exhausts all the resources available, either way, reinforcing feedback loops drive in a direction. They drive up or down until they exhaust either themselves or the resources available. I'm sure you can think of examples in your life of reinforcing feedback loops. Compound interest in a bank account is an example of one. You have some money, interest gives you more money, you now have more money, so you get more interest, so you get more money, so you get more interest, so you get more money. That's a reinforcing feedback loop. But there are other types of feedback loops. There's this one called a balancing feedback loop. In this case, we're going to talk about rabbits, with an EU symbol for some reason, the euro, and grass. Now, our intuition would tell us if there's more grass, we're going to get more rabbits. But if there's more rabbits, we're going to have less grass. Because there's less grass, we get less rabbits. So then that gives the grass a chance to grow, and we get more grass. And it cycles back and forth. This is called a balancing feedback loop because the interactions between the nodes balance each other out. This leads to something that's a kind of equilibrium or a stability in the system. It means that while, yes, we'll have oscillations, it'll go up and down over time, hopefully it never grows so much that it exhausts itself. This is actually a characteristic of systems that are more resilient and stable over time. There's another kind of reinforcing feedback loop that it's worth taking a look at, which is kind of a competition feedback loop. So we have hares and rabbits, and they're in competition for resources. So if we have more hares, we'll have less rabbits, but because there's less rabbits, there'll be more hares, and so on. This is another reinforcing feedback loop. We can understand it that way because the characteristics are driving towards the limits in either direction. But unlike the first reinforcing feedback loop, which was driving all up or all down, this is driving one side up and the other side down. Sometimes we see reinforcing feedback loops doing something that we want, like getting us more money in a bank account, and we might call that a virtuous cycle. Sometimes we see reinforcing feedback loops doing things that we don't want, like driving populations extinct, and we call that a vicious cycle. So reinforcing feedback loops, there's no judgment about them. They can make things grow, they can make them shrink. It depends on the circumstance whether that's good or bad for you. While balancing feedback loops keep things stable and in equilibrium over time. So let's bring all these feedback loops together and see what happens. If we start by saying we have more rabbits, we've got a lot going on here now. We've got our reinforcing feedback loop, which is adding more baby rabbits and more rabbits. We've got our balancing feedback loop with the grass. We've got another balancing feedback loop between grass and hares, and we've got our competition loop between the rabbits and the hares. If I speed this thing up, it sort of gets us to a sense of, what this might look like over time in a sort of semi-steady state. And we can see here that in this case, the balancing feedback loops are actually strong enough to counteract the effect of the reinforcing feedback loops. And so maybe, if your goal is to have a steady ecosystem of rabbits and hares, this is a good thing. If you're following so far and you're looking at some of these diagrams, they might look kind of familiar to you. Since you're coming to Domain-Driven Design Europe, I'm imagining you've read Alberto's book on event storming, in which he draws this diagram, which is a kind of causal loop diagram. If you look closely, there's actually no loops in this diagram, but it doesn't matter because it tells the story he wanted to tell about what's happening in organizations. If you ignore the orange text, it describes an organization that is weighed down under the cost of consensus and decisions piling up, leading to a clogged organization. When you add the orange text, which is the effect of introducing a practice like event storming, we can see that it counteracts some of those negative effects. So you've already seen causal loop diagrams used in action as a kind of intuition pump, a storytelling device to help you connect with and understand what's happening. So let's take a look at causal loop diagrams in software development. The first one we're going to look at is a very simple, naive diagram. This is, I think, what lots of investors would like software development to be like. We have a rate of new requirements being produced, perhaps once per cycle, per sprint, a rate of new software being produced, and a rate of new value being delivered to our customers. If we increase the rate of new requirements, we increase the rate of new software production, we increase the rate of new value production. And we can just keep doing that, and everything's great until we're just a machine humming along, delivering heaps of software and heaps of value. If only it were so. Of course, we have the reality that sometimes we produce bugs. We have new requirements, new software, but that creates new bugs, and new bugs detract from the value that is delivered to our customers. Once again, there's no feedback loops here, so you'll see it kind of settles into a steady state very quickly. But once again, this is just a model. It doesn't represent reality. It's just a storytelling device. And I think what's going on with people when they say, no, you can't fix the bugs, is that they're worried about the time that's going to be spent fixing them, and that time is going to take away from the time spent adding value. So we can see here in this example, we end up with time spent fixing bugs, which reduces the time to add value, which reduces the value that's being delivered. But eventually, we fix the bugs, we can get back to adding value and deliver some value, but then we start adding more bugs again. So this is actually an example of a feedback loop in action. Does anyone recognize what type it is? Is it reinforcing or balancing, do you think? Balancing, yes, thank you. Exactly. So it's balancing because you can see it's not driving to the limits in either direction. One way that you can recognize balancing feedback loops is that you have an odd number of opposing links. These links here with this symbol, which represent that if this one goes up, the other one will go down. If you have an even number of these, they cancel each other out, and you end up back with a reinforcing loop. But in this case, we have an odd number, just one, and so we have a balancing loop. But even this doesn't really tell the full story, does it? As much as that's the fear, we can see then that what people are trying to do when they say don't fix the bug is, they're obviously not going to not fix a really important bug, but they have this notion that we can split our bugs into low-impact bugs and high-impact bugs. I've made the high-impact bugs a smaller circle down there in the hope that there's less of them. And we can kind of see this model in action where we end up with an oscillating rate of new bug production because we have an oscillating rate of new value production or new work being done. And so there's this theory that if we just leave the bugs aside and only fix the high-impact bugs, then maybe we'll end up having less of an impact on our ability to deliver value into production. But the reality is, and I think this is at the heart of why the iron triangle intuition pump doesn't work, is that there are actually other reinforcing feedback loops at play here. In fact, the bugs that are created, even if they're low impact, if they're not addressed, they contribute to confusion. And confusion increases the likelihood that we're going to have more bugs, both low and high impacts. What I mean by confusion is confusion in the software team that's trying to modify the software. Who's been in a situation where you have a bug that you know about, that you've been told not to fix, and every single delivery cycle, someone finds the bug and says, sorry, what's this going on? We need to investigate it. You investigate it. Yes, sorry, no, that's a known issue. And it wastes a whole heap of time, right? Who's seen that? I certainly have. And so I think what's going on here is this reinforcing feedback loop that actually means that by not fixing those bugs, we increase confusion and actually affect our ability to continue to deliver value into the future. So if we look at what this one looks like, we end up with this reinforcing feedback loop dominating, maximum confusion, steady rate of bugs being produced, lots of time spent fixing the bugs, and very little value being delivered to production. And this is something that will occur in the long term as the cumulative effect of those bugs and confusion starts to arise. But bugs are not the only problem. We also have this notion of cruft. Cruft you might think about as being technical debt. I don't like the term technical debt. I think it's misused in a lot of cases, but it's that little stinky present that our team before was leaving in the corner for themselves. Again, a very naive view is that, so what? We'll produce new cruft, we'll just keep delivering value. The cruft doesn't have an impact, does it? Obviously, that's not correct. But once again, there's a fear that belies that, that's behind that assertion or that belief, which is that the time spent refactoring will do very little for the team rather than just reduce the value that we can deliver in that cycle. And this is a very kind of linear style of thinking because you're not contemplating the cumulative effects of those reinforcing feedback loops. And so, as I'm sure you can probably guess by now where this is going, is that we're going to end up with a reinforcing feedback loop here between cruft and confusion leading to heaps more time spent making sense of things. And if we speed this one up, much like the last one, we'll end up in a world with lots of confusion, very little new value being delivered, and an increasing rate of new cruft production. Is this intuition pump striking with you? I think, much like the stories I told earlier, this is probably something that you're starting to recognize in your teams. This runaway train effect, once it gets bad, it just keeps getting worse. So let's take a look at what happens if we put it all together. We've got our new cruft reinforcing feedback loop, our new low impact bugs and high impact bugs feedback loops with confusion. We do have some balancing feedback loops here, which is that any time we spend either trying to make sense of things or fixing the high impact bugs is time that we're not changing the code, so we get a reprieve and we're not adding more cruft or bugs for that period of time. But in the end, the reinforcing feedback loops dominate, and we'll have a look at this one, is that we end up with, once again, high confusion, lots of time spent trying to make sense of what's going on, lots of bugs, very little new value being produced. And once again, this is a long-term effect of taking this kind of stance. I think that one of the ideas at the heart of this, which strikes to why there's a difference of opinion between people who believe that you can make this trade-off iron triangle style and those that recognize that you can't, is a distinction between external quality and internal quality. An idea that was beautifully explored by Martin Fowler in this article is high-quality software worth the cost. He characterizes external quality as things like user experience or missing functionality, and internal quality, which I've been calling cruft, as confusing design, tight coupling, low cohesion, and poor abstraction. So low internal quality is what I'm representing here. High cruft, low internal quality. Now, the interesting thing about internal quality is that it's invisible to stakeholders in the short term. It's invisible to them because it's really only visible to the engineers who are working in the team. It's anything that affects our ability to make sense of the code and to change it, as represented on those loop diagrams before by that confusion bubble that kept blowing up to maximum. Because as we've seen in those diagrams, and as we've all experienced, its effects are felt in other ways, which is this growing sense that we just don't know how to change the code. So if we go back and look at the iron triangle and the good, fast, cheap, choose two concept, we can see that the presence of a reinforcing feedback loop between two corners of the triangle is what breaks the notion that they can be traded off. We think we can trade them off in a very linear mindset. The notion that it's just we push one, the other one gives, and that's all that happens. But because of this feedback loop, we push one, the other one gives, the feedback loop feeds it back around, and we end up in a reinforcing feedback loop that drives us towards decay and eventual collapse. So it doesn't work for software. If we are working with people who need this iron triangle, they need this intuition pump to make sense of things, this distinction between external and internal quality is something that might help them. If you can educate them about the difference between these two, you can let them make those trade-off decisions about the visible things that they can see, but protect your internal quality off to the side. And this brings me back to the title of this talk, Defending Technical Excellence, which we can now understand as the job of protecting the internal quality of our systems. To understand this a little bit further, to understand what is this confusion idea that we've been talking about, I'm going to turn to Peter Nauer. He wrote this wonderful paper called Programming as Theory Building. If you've heard of Peter Nauer, you might know he won the Turing Award in 2005. He co-created the Backus-Nauer form, expressing programming language syntax. truly someone who had a significant impact on computer science and our sector over time. I've highlighted the parts of this paper that I particularly like and which are relevant for this story, which is that he has this notion that programming is actually theory building, that an essential part of any program is the theory of it. It's something that cannot be conceivably expressed but is inextricably bound to human beings. It's the theory in our heads of how things work. He then goes on to describe this notion of the life cycle of a program as one of life, death, and revival, and says that the death of a program happens when the programmer team possessing its theory is dissolved. A dead program may continue to be used for execution in a computer and to produce useful results. The actual state of death becomes visible when demands for modifications of the program cannot be intelligently answered. Revival of a program is the rebuilding of its theory by a new programmer team. So using Peter Nauer's concept, I think that we can characterize confusion as the absence of a theory of a system, or perhaps not complete absence, but an incomplete theory or an inaccurate theory, something that affects our ability to reason about the system we're trying to work in. And so if we task ourselves with the job of defending technical excellence, we need to think about how can we defend that theory of the program? How can we build the theory of the system? How can we reduce confusion for the teams by helping them build that concept in their minds? You're at DDD Europe, so I'm sure you've heard of some of these techniques, but I'm just going to take a bit of a survey of some that I've found helpful over time. The first is some form of collaborative design. Illustrated event storming here, where we gather together groups of people from across the business. Some of them know some part of the world, some of them know other parts of the world, but the key thing is our engineers need to understand the domain. And the conversations that are driven by this kind of collaborative work help them build theories about the domain, build a cohesive and coherent theory about the domain. It has a lot of other positive effects as well, but for the purposes of today, that's what we're interested in. You could replace with domain storytelling or other collaborative modeling techniques, or as I heard Eric Evans once describe it, Fingerspitzengefühl, which is this sense of like the tingling in the fingers when you sense the domain. But either way, there's a concept of doing collaborative design, talking to people, knowledge sharing, and understanding what's going on that helps us build theories about the domain. I've spent the last 3 days learning about residuality theory from Barry O'Reilly. And I wanted to add this in here because I think that it's an example of building theories about the business context. It's a lot more than that. It's more than building theories, and it's more than just the business context. But unfortunately, I don't have time to dig into exactly what residuality is all about here. But it's certainly a lot of fun, because I can't think of any other practice with which, as a straight-faced professional, you can sit down and contemplate what would happen if Godzilla attacked Antwerp. So I do recommend checking out residuality theory if you haven't done so yet, and see what kind of theories it helps you build about the world that you're living in your businesses. Another practice that I'm a big fan of, that I think helps with a form of theory building, is lightweight documentation. It helps us build theories about the design. Perhaps you've engaged with a practice like the C4 model, or using Structurizer to help you build documentation about your architecture. We're going to have a closing keynote today from Simon Brown, the creator of this technique. Very much looking forward to it. Or perhaps you could use architecture decision records to keep a capture of the key decisions that you've made in the history of your system in your repositories, so that future teams or your future selves can make sense of the design decisions that have been made. The third tool I'm going to mention here is one that's quite dear to my heart. It's actually a product I've been working on. It's called Contextive. It's for documenting your ubiquitous language in your domain. It's actually a sponsor of the conference, and if you've got your goodie bag there, you'll see a little flyer with a QR code. It's a free tool as an open source edition where you can store a glossary of your ubiquitous language in a YAML file in your repository. But if you follow that QR code, you can sign up for a waitlist for a 6-month free trial of a forthcoming SaaS product, which will allow you to document your glossaries in a wiki like Notion and still share them back into your IDE so that your developers can have clarity over the domain terminology while they're working on the code. I'm not going to dwell too much more on that, but if you find that curious, please come find me and have a chat later. Perhaps you don't have too much documentation, or perhaps you do, but another practice that can help you build theories about the design is something like the bite-sized architecture session format from Andrea Magnorski. This is a wonderful technique where you get together with a group of people, you spend just about an hour on it, or maybe an hour and a half. You spend a bit of time working together but alone to build your own diagrams of what do you understand about the system, and then you share them with each other and try and integrate them towards a coherent and cohesive knowledge base or diagram of what's going on in your system. I've used this myself and found it very valuable for sharing knowledge between teams. And in the language of the talk that I'm giving here today, It's about building theories about the design so that people have that theory active in their head and can keep the program alive. Another technique that I'm a huge fan of is test-driven development, which I think in this concept we can think about building theories about the code. We write a failing test, we make the test pass, and then we refactor. We can use this refactoring test to experiment, to try things out. This helps us build theories and understand how the code is working. And the presence of these tests helps us make sense when things go wrong. Observability is another one that I'm going to put in here because I think it helps build theories about the runtime. And since we're in a DDD conference, I'm going to talk about the fact that if you name your endpoints, your APIs, and your events and your queues using terminology of the domain, then hopefully your OpenTelemetry diagrams that represent the flow of events through your system will actually bear a somewhat striking resemblance to the event storming diagram that you produced early on in the process. Of course, they won't be perfectly accurate, but I think this is an interesting way to build theories about the runtime and understand what the system is actually doing in operations. So we take all of these different tools, and there are many more. This is not an exhaustive list. I'm sure you can think of some more that when you think about it through the lens of what is helping me and my team build and maintain a theory of the program, you'll consider some others. But now we're going to think about how do we bring this all together into a causal loop diagram. I'm going to return back to Donella Meadows for a moment, the author of the Thinking in Systems book, and reference this concept that she introduced called leverage points. Now, this is a big quote. I'm not going to read the whole thing, but just to draw attention to a couple of key points that she says. Complex systems are, well, complex. It's dangerous to generalize about them. And she says, what you read here is still a work in progress. It's not a recipe for finding leverage points. Rather, it's an invitation to think more broadly about system change. I wanted to reference these quotes because sometimes you find people showing you these leverage points as though they were written on stone by Donella and are handed out as being the official word of systems thinking theory. But as she said herself, this is a work in progress. These are born out from her experience, and they can certainly be helpful for us to pump our own intuition or to inspire us to think of ideas, but don't treat them as gospel. That said, there is one here that we are going to be looking at today as inspiration, which is number 8, balancing feedback loops. This idea that we can consider the strength of the feedbacks relative to the impacts they are trying to correct. And so this is really the crux of my defense of technical excellence, is that we can introduce practices like test-driven development and collaborative design. I'm not going to do an exhausting analysis of all those other techniques, but we can see here that they represent a sort of balancing feedback loop against the confusion that is being grown by the other things. I've shoved them here in the middle. Now, if I play this model, the world doesn't look perfect. We still get confusion from time to time, but compared to the other model, we're getting a lot more value produced, and we're existing in a much more equilibrium state rather than driving hard at maximum confusion and maximum pain. Just the existence of these practices that act as a sort of pressure against the inevitable decay caused by those other reinforcing feedback loops is the thing that enables us to defend technical excellence in our systems and to maintain that theory of the program in our teams. I mean, I could just leave this up for a while and we all just stare at it if you like. But we do have to move on. And so I'm going to just clarify one thing. And I've kind of been hinting at it through the talk, which is that we need to be really clear about what these causal loop diagrams are not. They're intuition pumps. They're not reality. They are not a simulation. They are not objective fact. Put another way, the map is not the terrain. All models are wrong, but some are useful, and the model is not the thing modeled. Do not draw a causal loop diagram and expect the world to play out the way it has shown you. Do draw a causal loop diagram to explore your own intuition, to see if it makes sense to you, to show it to someone else and see if it makes sense to them, and to spark a conversation that helps you both make sense of what's happening in your environment. And if you're lucky, use it to then drive some conversations that can help you create some interventions that will lead to a more positive environment. Now, I've left this slide till the end, but I kind of had to include it, right? Because I know I'm going to get a question. What does Gen AI code production have, and what sort of effect does Gen AI code production have on all of this thinking about theories of programs and collaboration and whatnot? Look, I don't have an answer to this question. I think it's still a very evolving space. I talk to some people who are desperately in love with it and never want to live without of it, and some people who think that it's going to burn down the planet. And it's just a very interesting time to be living in, where it feels like two completely parallel universes have collided, and some people are experiencing something in a very positive way, and some people experiencing it in a very negative way. But I think my philosophy on the whole thing is to contemplate the question, where is the theory of the program held? From what I've seen so far, I don't believe that the theory is held by the AI. AI does not have, or large language models does not have long-term memory in the way that we think about it. Every prompt is re-evaluated against the trained data set, but with perhaps an ever-growing set of context of previous interactions and code that's provided. But for many people, this is why eventually their AI-developed system collapses on them, and the AI can no longer continue to intelligently modify it, because it doesn't really possess a theory of the code. And once you've done that, and the humans don't possess a theory of the code either, you have to effectively consider the program dead, and its revival, as Peter now said, relies on somehow building back up a theory of the program, of how it works and what it's trying to do. The people that I am seeing who are getting a very positive outcome from using Gen AI are actively, whether they realize it or not, maintaining the theory of the program in the human beings. They're doing short steps. They're being strict with the AI about producing tests and then the code that makes those tests pass. They're reviewing the code so that they understand what it's doing and why, and how it's fitting together with the code that already exists there. And as a result, they're maintaining the existence of this theory of the program in their heads and keeping the software alive. So this is a speculative, opinion-led thought about this whole thing. I don't think that we're at the end of the journey, and we certainly haven't got any kind of predictive or helpful models of how to decide when and how to apply this tool, but it's certainly an interesting space to keep an eye on. So now that we've gotten to this level of understanding, I want to go back and talk about those stories that I shared right at the start, and think about perhaps what life could be like for our team. We have our product manager who comes along with a brand new product idea and adds it to the backlog. The development team gets started on the work, perhaps using test-driven development. Just because they're using TDD doesn't mean that they can't end up with a bug, and QA might find that for them, but they're given the opportunity to fix the bug before it goes to production, stopping that reinforcing feedback loop in its tracks and not letting it drive confusion in the team up. Perhaps we have our product manager come along with a brand new feature that gets added to the backlog. The team starts working on it, and they're given time to do collaborative design, in the understanding that this is not hampering our rocket ship to the moon, but in fact accelerating it, because it's not having the linear systems thinking effect of just a simple trade-off from value delivery, but it's blocking that reinforcing feedback loop and allowing us to maintain a stable, steady state of value production into the future. And thanks to that, with the design in place, the team can get working and deliver wonderful value to our customers and be a lot less stressed and unhappy in the process. So I'm going to leave you with a couple of takeaways now, just to summarize the key points from today. The first takeaway is that the iron triangle, as it's often formulated, does not work for software. If you're in an environment where people are insisting that they want to have some sort of trade-off decision-making, then perhaps let them do so with external quality, but protect internal quality as best as you can. I'd like you to consider this notion of technical excellence not as a specific technique or practice, but that as any practice that protects the theory of the program held by the team, that acts as a counterbalancing force against those reinforcing feedback loops driving confusion to the max and helping the team continue to intelligently answer questions about how to modify the system and the code. And the last takeaway is that causal loop diagrams are a lot of fun to play with. I recommend jumping on and checking out that Loopy tool, but you don't have to use Loopy. You can just go away and draw some diagrams, sketch them up on a whiteboard or on a piece of paper. You might get to the end of this talk and think, well, that's great, Chris, you've obviously drawn a whole bunch of diagrams. I don't think I feel confident just going away and starting to draw these things. And you know what? That's actually totally okay. Nobody learns anything sitting in an audience watching someone else do it. The only way you learn is to do it yourselves. So I do recommend go away, have a play around, share your causal loop diagrams with other people in your team and ask them if it makes sense to them. Are you helping each other prime your intuition pumps to make sense of the world and to consider the kinds of interventions that can help make things better for you? But do not, whatever you do, mistake their visualizations for objective facts. This is just an intuition pump, not a simulation of reality. Thank you so much for your time today. This QR code will take you to my website, which has both all of the slides and a whole bunch of references, books and articles. And on the slides, you can click through and actually click on the links to get to the diagrams that I've been playing with today, and you might like to spin them up and play around with them and see what happens if you add some connections or not. And with that, I'm going to invite you to connect with me. I love talking about this stuff. I'm on LinkedIn and Blue Sky. This will take you to my homepage. If you go and draw some diagrams and have some fun doing so, but get a bit stuck, feel free to reach out. I'd love to jump on a call and chat about it. And if anyone is interested in that contextive tool, also very happy to chat. I'm at the conference for the next 2 days and very keen to speak with as many people as possible. So thank you so much for coming this morning. I hope you have a lovely day, the rest of the conference and tomorrow. And yeah, appreciate your attention. Thank you.